Welcome to WikiPodcast. You've tuned in to The Deep Dive, your shortcut to being truly well-informed. Today we're embarking on an extraordinary journey. It's part of our History Makers series, focusing on scientific geniuses. And we're diving deep into the life of, well, arguably the most famous scientist ever, Albert Einstein, the man who bent time. You know the iconic image, right? The wild hair, the profound equations. But do you really know the full story? The person behind the genius? Our mission today is to trace Einstein's journey from this incredibly curious child to the revolutionary scientist whose ideas just completely reshaped how we see the universe. We'll uncover some surprising bits about his personal life, too, and explore the legacy that made him, well, one of history's most impactful minds. So where does this incredible story truly begin? He was born in Ulm, Germany, 1879, his early life. It seems like there were already hints of where he was headed, scientifically speaking. What was it right at the start that really ignited that spark, that curiosity?
Well, the story often told, and it seems quite pivotal, is about a simple compass. His father gave it to him when he was sick in bed.
A compass.
Yeah, and apparently he was just mesmerized by the fact that needle always pointed north. He felt this deep sense that something deeply hidden had to be behind things. And this wasn't just a fleeting childhood thing. It really drove him. He taught himself algebra and calculus by the time he was, what, 14?
14, wow.
Yeah, and he even came up with his own proof for the Pythagorean theorem. He had this core belief that nature, it could be understood as a kind of mathematical structure.
Okay, so clearly brilliant, a prodigy even, but maybe not the easiest student in a traditional classroom. Read he found rote learning kind of harmful to creativity.
Exactly. He wasn't a fan of the rigid German education system at the time. He clashed with authority, didn't like just memorizing facts.
So a conventional school wasn't quite his thing. Where did he eventually land, academically speaking?
He eventually found his way to the Swiss Federal Polytechnic School in Zurich. He went there to get a teaching diploma in mathematics and physics.
Switzerland.
Right. And Zurich was important personally, too. That's where he met Mileva Maric. She was a fellow physics student, one of the few women in the program. They shared this intense intellectual passion, which grew into a relationship. They eventually married and had two sons, Hans Albert and Edward. There was also a daughter, Liesel, born before they married, but her fate, well, still a bit uncertain, kind of lost to history.
Right. So after graduating, he ends up working at the Swiss Patent Office in Bern. That seems, well, a bit unexpected for someone who just changed physics.
It does seem unlikely, doesn't it, a patent clerk? But 1905, while he was there, became his annus mirabilis, his miracle year.
The miracle year. Okay, unpack that for us. What was so miraculous about 1905, especially happening from behind a desk looking at patent applications?
Oh, it's just astonishing. While working as an assistant examiner, looking at things like electrical signal transmission, clock synchronization, which might have actually helped his thinking.
Interesting connection.
Yeah. He publishes 4 papers, not minor papers, 4 groundbreaking papers that just completely rewrote the rules of physics.
4 in 1 year from the patent office. Yeah. Okay, you have to walk us through these. What were they?
Okay, so the first one, it tackled the photoelectric effect. The phenomenon where light hitting a metal surface can knock electrons loose.
Right, I've heard of that.
Classical physics couldn't quite explain it properly. Why did the color of the light matter more than the brightness sometimes? Einstein proposed that light isn't just a wave. It also acts like it's made of tiny packets of energy, particles.
Later called photons.
Exactly, photons. And only a photon with enough energy, depending on the light's frequency or color, could kick an electron out. This was huge for the developing quantum theory, and it's what eventually won him the Nobel Prize in 1921.
Okay, 1 down. What was next?
Then he explained Brownian motion. You know how you sometimes see dust motes dancing randomly in a sunbeam? Well, scientists had seen tiny particles suspended in liquid doing this weird, jittery dance under a microscope. Einstein showed, mathematically, that this jittering was caused by the constant bumping of invisible, smaller molecules.
So it was proof, like visible proof, that atoms and molecules were real, because that was still debated, right?
Absolutely. It was really strong evidence for the existence of molecules, which many scientists still consider just a convenient theoretical idea. So that was paper number 2.
Incredible. Okay, number 3. This is where relativity comes in, I assume.
You got it. His special theory of relativity. The big problem was that the laws of physics for motion, Newton's laws, didn't seem to mesh properly with the laws for electricity and magnetism, Maxwell's equations, especially concerning light. Einstein's radical idea was built on 2 postulates. One, the laws of physics are the same for everyone who isn't accelerating, and two, the speed of light in a vacuum is constant for all observers, no matter how fast they're moving.
That second one, that's the real mind bender, isn't it? The speed of light is always the same.
It is, and the consequences are profound. It means that our common sense notions of space and time are wrong. Time can slow down and lengths can contract depending on your relative motion. Space and time are interwoven space-time.
Wow, okay. And the fourth paper from this miracle year, the most famous equation of all.
Yep. As a kind of follow-up or consequence of special relativity, he derived EMC fall, the mass-energy equivalence.
Energy equals mass times the speed of light squared.
That's the one, often called the world's most famous equation. It basically showed that mass is a form of energy, and energy has mass. They're interchangeable. This laid the theoretical groundwork for nuclear energy.
So, just to recap 1905, he explains light as particles, provides proof for atoms, rewrites space and time, and gives us E and SRIO, all while working as a patent clerk.
Pretty much. It's why they call it the miracle year. It just laid the foundation for so much of modern physics.
Absolutely staggering. But special relativity, as huge as it was, wasn't the final word from him on space-time, was it? In 1915, he introduces his general theory of relativity. How did this take things even further?
Right. Special relativity dealt with constant velocity, but it didn't include acceleration or, crucially, gravity. General relativity was his theory of gravity. And it was another revolutionary leap. Instead of gravity being some mysterious force pulling things together like Newton thought, Einstein proposed that gravity is actually the result of mass and energy warping space-time itself. Think of space-time as a flexible fabric. Put something heavy on it, like the sun.
It creates a dip, a curve.
Exactly. And planets orbit the sun not because they're being pulled directly, but because they're following the curves in space-time created by the sun's mass. Gravity is the curvature of space-time.
That's a beautiful, almost geometric way of thinking about it. But again, how on earth do you prove something like space-time being warped? That sounds incredibly abstract.
It does. But Einstein's theory made specific, testable predictions. One was that light itself should follow these curves in spacetime. So light from a distant star passing near a massive object like the sun should appear to bend.
And that's where the famous eclipse expedition comes in, right? 1919.
Precisely. Sir Arthur Eddington led expeditions to observe a total solar eclipse. During the eclipse, with the sun's glare blocked, they could photograph the stars near the sun.
And did the stars appear to shift position, like Einstein predicted?
They did. Their apparent positions were deflected by the sun's gravity, just as general relativity calculated. It was a stunning confirmation.
What was the reaction to that?
It was huge. The news flashed around the world. I think the New York Times ran a headline like, "Revolution in Science, New Theory of the Universe, Newtonian Ideas Overthrown." It instantly catapulted Einstein from being a respected physicist to a global superstar.
Like the world's first science celebrity.
Pretty much, yeah. Suddenly everyone knew his name, even if they didn't understand the theory. He became this icon of genius.
And he started traveling extensively after that, didn't he? How did he handle this newfound fame?
He did. He toured the U.S., Asia, Palestine. He was greeted like royalty mayors, university presidents, even emperors wanted to meet him. He used the platform not just for science, but also to speak out for pacifism and international understanding.
How did he find the places he visited? Like America.
He seemed quite taken with America initially, admiring the joyous, positive attitude to life he saw. He also appreciated Japanese culture, noting their true appreciation of art, though it's fair to say some of his private diary entries revealed less flattering views of other groups he encountered.
Right, complexity again.
Yeah.
But this period of fame and travel, it coincided with darkening clouds in Europe, particularly in Germany.
Yes. By the early 1930s, things were changing dramatically. In 1933, while Einstein was actually visiting the U.S., Adolf Hitler came to power.
And Einstein was Jewish, and already a vocal opponent of the rising nationalism.
Exactly. He was horrified by the Nazi persecution of Jews and their political opponents. He knew he couldn't go back. He decided to remain in the United States and formally renounced his German citizenship.
What happened back in Germany?
The Nazis basically declared him an enemy. They raided his property, publicly denounced his work as Jewish physics, and even put a bounty on his head. It was incredibly dangerous. He found a safe haven, though, at the Institute for Advanced Study in Princeton, New Jersey.
Which brings us to another really difficult, complex chapter, his connection to the development of the atomic bomb. How did Einstein, who is so deeply pacifist, get involved?
It's one of the great ironies, isn't it? He genuinely believed war was a disease. But on the brink of World War II, other scientists, particularly fellow refugees from Europe like Leo Szilard, became terrified that Nazi Germany might be developing nuclear weapons.
They realized the implications of EMCR.
They did. And they knew the Germans had excellent physicists. So Szilard and others convinced Einstein, because of his stature, to sign a letter to President Franklin D. Roosevelt.
The famous Einstein-Szilard letter.
Right, urging the U.S. government to start its own nuclear research program as a deterrent, just in case the Germans succeeded first.
Did he regret that later?
He did. He famously called signing the letter the one great mistake in my life. But he also justified it by saying there was a real danger that the Germans would make them first. It was a terrible dilemma, driven by the fear of a far worse outcome.
A profound moral weight to carry. Beyond the war effort, though, he also became quite active in his adopted country on another front. Civil rights.
Yes, very much so. He became a U.S. citizen in 1940, and he was deeply troubled by the segregation and racism he witnessed. He called racism America's worst disease.
Strong words.
He backed them up with action. He joined the NAACP, corresponded with figures like W.E.B. Du Bois, and publicly advocated for the rights of African Americans.
Oh.
There's a famous story about the black contralto Marian Anderson.
Oh, the singer.
Yes. When she was performing in Princeton, the local hotels refused her accommodation because she was black. Einstein invited her to stay at his own home. He often drew parallels, saying, being a Jew myself, perhaps I can understand and empathize with how black people feel as victims of discrimination.
That's powerful. Moving into his later years, after the war, did his scientific focus shift?
He continued working tirelessly, mainly at Princeton. His big goal in those later decades was to find a unified field theory.
What was that exactly?
He was trying to find a single mathematical framework, one set of equations, that could describe both gravity, general relativity, and electromagnetism. Kind of a theory of everything as it existed then.
Did he succeed?
No, unfortunately. It proved incredibly difficult, and he never achieved that final unification he sought. Physics was also moving in directions he wasn't entirely comfortable with, particularly quantum mechanics.
Ah, yes. His famous skepticism about quantum theory's randomness. God does not play dice.
Exactly. He acknowledged quantum mechanics worked, its predictions were accurate, but he felt it was incomplete. He couldn't accept that the universe operated on fundamental chance at its deepest level. He believed there had to be underlying deterministic laws we just hadn't found yet.
It ties into his broader philosophical views, doesn't it?
Mm-hmm.
He called himself a deeply religious non-believer.
Mm-hmm.
How did you reconcile that?
It's fascinating. He rejected the idea of a personal God who intervenes in human affairs. He saw the word God as an expression of human weakness. But he had this profound sense of awe and wonder at the harmony and intelligibility of the universe, the elegance of the physical laws. That for him was a kind of cosmic religious feeling, a belief in maybe Spinoza's God as nature, as the underlying order.
So the God in God Does Not Play Dice was more about that inherent orderliness he believed in.
I think that's a good way to put it, yes. It reflected his faith in a rational, predictable universe, even if quantum mechanics seemed to suggest otherwise at the time.
Beyond the science and philosophy, there was music too, right? He was quite an accomplished violinist.
Oh, absolutely. Music was incredibly important to him, a lifelong passion. He started playing the violin as a child. He once said something like, "If I were not a physicist, I would probably be a musician. I often think in music. I live my daydreams in music."
Who did he like to play?
Mozart was a huge favorite. Bach, too. It was clearly a source of relaxation, inspiration, and maybe even a different way for his mind to connect with that harmony he sought in the universe.
The truly multifaceted person. He passed away in 1955 at the age of 76. And even his death had a certain Einstein-ness about it.
It did. He suffered an abdominal aortic aneurysm, and doctors recommended surgery. He refused. He reportedly said, "I want to go when I want. It is tasteless to prolong life unofficially. I have done my share. It is time to go. I will do it elegantly."
Wow. Accepting the inevitable with grace.
Yeah.
And his legacy. Well, it's almost immeasurable.
It really is. Over 300 scientific papers, more than 150 non-scientific works. He's consistently ranked as one of the greatest physicists, if not the greatest. Time magazine's Person of the Century in 1999. His name is literally synonymous with genius. And his work isn't just historical. General relativity is fundamental to our understanding of black holes, gravitational waves, the expansion of the universe. GPS systems even need to account for relativistic effects to be accurate. His ideas are still shaping how we see the cosmos.
So what does this all mean for you, our listener? Albert Einstein, the man who bent time. He was just such a force of nature, this incredibly curious child who became a scientific revolutionary, yes, but also a humanitarian, a complex individual navigating incredibly turbulent times. His life was truly as intricate and, well, as fascinating as the universe he dedicated his life to understanding, his intellectual courage, his relentless questioning, and that deep drive to comprehend. It's something that continues to inspire, doesn't it? Thanks for listening. Write us your opinion in the comments on how Einstein's blend of scientific inquiry and deep humanitarianism inspires you. Subscribe to the channel to help more listeners reach our episodes. Thank you and have an amazing day.